All right, let's jump right into this explainer and begin our descent to the metal. We're going to strip away all those glossy, high-res screens you stare at every single day to uncover the grand illusion of modern computing interfaces, and ultimately, we're going to see who's actually in control here. So, have you ever stopped to wonder why some of the greatest master storytellers alive today choose to work on what is basically ancient software? I mean, we're talking about George R. Martin using WordStar 4 from way back in 1987, and Robert J. Sawyer rocking WordStar 7 from 1992 to write these massive, complex, world-building epics. In an era of endless apps, cloud syncing, and AI writing assistants buzzing all around us, why on earth are these brilliant creators deliberately choosing to write their masterpieces on a 40-year-old, totally blank DOS screen? Well, consider the stark contrast between the environments we use today versus those classic setups. On one hand, our modern word processors act more like heavy, distracting designer tools, right? They're packed with graphics, drop shadows, pop-up notifications, just a ton of visual bloat that you constantly have to fiddle with just to get a single sentence down. But on the flip side, that stark, blank DOS screen acts as a pure, hyper-focused writer's tool. There's absolutely nothing there until you start typing. It's literally just you, your intent, and the text. There's no machine trying to guess what you want or distracting you with formatting tweaks. And this brilliantly illustrates a much wider problem with our modern systems. It's captured perfectly by the free software legal scholar Eben Moglen, who said, "We get the chimpanzee hitting buttons, but we chat with each other. We could be hitting buttons, but it isn't as good." Just think about that for a second. Graphical user interfaces, or GUIs, essentially reduce us to this point-and-grunt caveman interface. We happily trade the incredibly rich, profound nuance of human language just to pull a colorful digital lever for a quick dopamine hit. We've basically stopped communicating with our machines and started just pressing whatever shiny shapes they put in front of us. Because of all this, the GUI is actually a technological dead end for true automation and expression. Look at the limitations we've boxed ourselves into here. First off, GUIs require massive computational power just to render these visual illusions, the windows, the shadows, the little cursors. Second, if you actually want an AI or a script to automate a task, it has to rely on incredibly fragile screen scraping. That literally means the computer is blindly guessing what to click based on pixel colors. If a website updates and shifts a button by a single pixel, bam, the entire automation violently breaks. By relying on these shiny buttons, we are completely dumbing down our ability to express complex, robust thoughts to our machines. Let's move into section 1, down to the silicon, and look at the hardware reality. So deep inside the physical brain of your computer, way beneath all that software, there's a massive clash going on between two very different hardware components. On the left, we have the floating point unit, or, as we can call it, the FPU gambler. It is wildly fast, sure, but it relies entirely on lossy approximations. It uses these completely secret proprietary seed tables burned right into the chip to essentially throw darts at a dartboard to guess complex math. It's fast, but it's a guess. But on the right, we have the arithmetic logic unit, the ALU surveyor. The ALU deals strictly in exact 100% deterministic mathematical truth. With the ALU, 1 plus 1 is exactly 2 every single time on every single machine on Earth. Zero guessing involved. And here is the truly staggering reality of our modern technological boom. 80 to 90% of modern AI compute cycles are actually just FPU hardware-level approximations. When these massive language models do their heavy lifting to generate text or images, they aren't giving you an exact mathematical truth. They're fundamentally just guessing the nearest answer that's hardwired into the silicon. To put it into perspective, your cutting-edge AI is essentially a highly sophisticated dart thrower, leaning on probabilities rather than absolute certainties. And relying so heavily on that guessing hardware creates what researchers actually call the wood chipper effect. When this non-deterministic FPU hardware just guesses the math, the exact path of that data, its provenance, is permanently destroyed. It irreversibly chops up the original data like a fruit smoothie. You might know exactly what fruits you tossed into the blender, but you can never perfectly reverse engineer that smoothie back into its exact original components. Once the hardware guesses, the original truth is lost forever, completely shredded by the lossy math. Which brings us to section 2, the LPU deterministic revolution. Now, this shift toward deterministic hardware is so absolutely critical that back in December 2025, NVIDIA executed an unprecedented $0 billion acqui-hire licensing Grok's LPU IP. Just think about how wild that is for a second. A major player securing this intellectual property for $0 upfront just to fundamentally shift their architecture. This incredible move marks a massive industry pivot. We're moving away from the era of massive model training, which, remember, relies heavily on those FPU approximations, and we're shifting focus heavily toward local, real-time deployment where exact, deterministic logic is absolutely non-negotiable. So why exactly is this new architecture winning? Well, traditional GPUs were built for parallel training, but they inevitably hit a massive bottleneck known as the OL² memory wall. Because they constantly have to fetch data from high bandwidth memory that sits off the chip, they suffer from severe execution jitter. It's exactly like a master chef constantly having to run out to a grocery store down the street right in the middle of cooking a meal. It just doesn't work. But language processing units, or LPUs, are completely different. They keep massive amounts of SRAM memory right there on the chip itself for specialized sequential inference. They completely eliminate that memory wall bottleneck, allowing the processor to deliver absolute bit-level truth without ever leaving the kitchen. All right, let's pull all this together in Section 3, Text as Universal Interface. There is an incredible modality gap between you and your machine. On one side, we have our own human cognition, what we can affectionately call OS alpha. It's warm, it's highly associative, probabilistic, and honestly, beautifully messy. But on the exact opposite side of that physical chasm, we have the computer's ALU. It is cold, it is rigid, and it is strictly deterministic, operating entirely on the relentless metronome of discrete clocked voltages. These two modalities literally couldn't be more different from one another. To successfully cross this terrifying gap, we use what's called the semiotic bridge. Here's how it works. First, you start with your abstract, messy human desire. Second, you formalize that intent into strictly formatted code, like a JSON or Python file, what we can call the divine script. And finally, third, that perfectly formatted text triggers exact physical ALU execution. By taking the time to write explicit text, we are quite literally tricking rocks into thinking using lightning and text. It's the ultimate translation of human will into physical reality. Which brings us right back to our DOS writers, and really proves the absolute superiority of pure text and the command line interface, or CLI. By bypassing all that heavy GUI bloat, the CLI provides 100% exact text logs and lightweight direct communication with the hardware itself. It gives you complete rhetorical control over the machine. When you reject the probabilistic guessing of the hardware and choose instead to wield explicit text, you lock in absolute truth on deterministic silicon. You preserve your pure, unfiltered human authorship without any of those shiny buttons getting in the way. As we wrap up this explainer, I want to leave you with a final, provocative thought. If you blindly rely on the bloated visual illusions of GUIs and the non-deterministic guessing of FPU hardware, who really controls the physics of your machine? Are you going to be a passive consumer, letting the hardware just guess what you want? Or will you seize the divine script and reclaim your authorship from the automated noise? The choice is entirely yours. Thanks for joining me on this explainer, and keep exploring.